Hello students, welcome to Eduauraa. I am Swati Moona, your chemistry mentor, and we are here to discuss past year question. The correct statement regarding the binary carbonyl compounds for transition metals is option A, total number of valence electrons at metal center in FeCO5, that is pentacarbonyl iron, or NiCO4, that is tetracarbonyl nickel, is 16. Option B, these are predominantly low spin in nature. Option C, metal-carbon bond strengthens when the oxidation state of metal is lowered. And option D, the carbonyl bond, that is CO bond, weakens when the oxidation state of the metal is increased. Students, this question was asked in Advanced 2018. Students, in order to find our correct statements, let's look at the given options. Option A. Option A states that the FeCO5, that is pentacarbonyl iron, and NiCO4, that is tetracarbonyl nickel, should have 16 valence electrons. But students, these complexes have 18 valence electrons. Also, option B. Option B says that they should be a predominantly low spin complexes. Students, carbonyl ligand, that is the CO, carbonyl ligand, is a strong field ligand. And strong field ligands always cause pairing of electrons and utilizing the inner orbitals. As a result, the complexes are always low spin complexes. Option C. Option C states that metal carbonyl bond. Option C. Option C states that metal carbonyl bond strengthens when the oxidation state of the metal is lowered. Students, when the oxidation state of the metal is low, the electron density on the metal is quite high. As a result, the synergic bond, rather the synergic effect, is also quite high. As a result, the bond becomes stronger. That is, the metal-carbon bond strength increases. Looking at the option D, which says the carbonyl bond weakens when the oxidation state of the metal is increased. So students, as we discussed, when the oxidation state of the metal increases, the electron density decreases. As a result, the synergic effect also decreases, thereby strengthening the carbonyl bond rather than weakening it. So students, we can conclude that the correct options are option B and option C. Moving on to the next question. Students, this question was asked in Advanced 2018. It says, match each set of hybrid orbitals from list 1 with the complexes given in list 2. The list 1 says that A, DsP2, B, sp3, C, sp3d2, and D, d2sp3. List 2 has the list of complexes. First one, P, which is FeF6 4-, Q, which is TiH2O3 times Cl3, R, which is CrNH3 6 times 3+, S, which is FeCl4 2-, T, which is NiCO4, and W, which is NiCN4 the whole 2-. Students, we need to match the two columns, and the option given to us are option A with T, B with S and W, C with Q and R, and D with P. Option B, A with T and W, B with S, C with Q, and D with P and Q. Option C, A with W, B with S and T, C with P, and D with Q and R. And option D, A with S and W, B with T and W, C with P and Q, and D with R. So now students, in order to find the correct matches, let's work at the given complexes. Let's look at the complex 1, which is FeF6 4-. Students, FeF6 4- has fluoride as the ligand, and fluoride ligand is a weak field ligand. And the hybridization for this complex will be sp3d2, that is the outer orbital complex or the high spin complex. Looking at the second complex, that is Ti, H2O thrice and Cl3. Here, the hybridization will be D2sp3, that is the inner orbital complex, since there is no effect of the ligand field strength. Next complex, which is CrNH3 6 times 3+. Here, ammonia, which is a strong field ligand, also uses the inner d orbital, making the complex to be D2sp3. The next complex, which is FeCl4 2-, has chloride ligand, a weak field ligand, causing the hybridization sp3. The next, which is NiCO4 carbonyl ligand, which is a strong field ligand. The hybridization here is sp3. And the last, that is NiCN4 2-, again, cyanide being a strong field ligand causes a hybridization of dsp2. So students, our correct option here will be option C. So students, these were the advanced and mains level past year questions. Hope you have enjoyed the session. This is me, Swati Moona, signing off. Keep learning, keep practicing, and thanks for watching Eduauraa.